Alright, in this video I want to show you how to come up with the graphs of the three main trig functions, and those are sine, cosine, and tangent. So the first two terms that we need to know would be the terms that you see listed right there, the amplitude of a function and the period of a function. So here's a real simple explanation of that, or a real brief kind of sketch of that. It's not a very straight line. Let me see if I can make that look a little bit better here. So let's suppose we had the following axis right here, and we're going to graph something that looks like a trig function. So it's going to be, it's basically going to be a kind of like a wave-like function. You might have seen pictures of that before with sine and cosine, but it will be kind of a wave-type function. So let's say we have something that looks like this, and it obviously keeps going forever. That's what those arrows mean. Alright, so then let's suppose that this point right here is 3, and let's suppose this point down here is -1. And we want to find, actually this arrow should then dip upwards after that, so we want to make sure that it goes no further below that than -1. So what is the amplitude, what's the period? And let's suppose this is 90 degrees, let's suppose this is 490 degrees, let's say, and this is 290 degrees. So first of all, the amplitude just means the height of the graph from the middle point to its peak, or from the middle point to the bottom. So by middle point I mean these green lines that I'm drawing right here. You can see that those are right in the middle of the graph. The amplitude would be this distance right here. So it looks like and easiest way to do this is find the total distance. So the total distance here would be from a peak of 3 to a minimum of -1. So we can just find the difference between those. That would be 4. Amplitude is half of that. So the amplitude actually would be right here at 1. It's more like, let me erase those so it doesn't look like it's going through 0. The amplitude is just the height from the middle of the graph to the top. Okay, so the middle of the graph would be right here at the halfway point, and the amplitude is going to be whatever height takes us from that middle point of 1 up to the top. Okay, so in this case the amplitude is 2. Amplitude is just half of this number right here, so that distance is 2. Or if you were to go down, if you were to go from +1 to -1, that would also be 2. So that's what the amplitude means. The period is how long does the graph take to go through a complete cycle. So the easiest way to measure this is look at the peak. The peak right here would be right there, and then see how much distance passes before I get to that other peak, that other purple dot. And it looks like we're going from 90 degrees to 490 degrees, so the period in this case would be 400 degrees. That's how much distance passes between 90 and 490. So with those ideas in mind, our goal here is we want to learn how to find those things just by looking at an equation, and then we will use those to graph. So here's our strategy. It's kind of 5 main steps. We start by making a table of values, and this is true for many functions that we've graphed. We've started out by making a table of values, so we'll do that to begin. So let's graph y equals sine of theta. In terms of what should be in our table of values, let me move over here so we have more space. The starting point of our table of values is going to be whatever it is that makes this thing right here 0, and that's what the parentheses means. In this case, we didn't put a parentheses around it, but here's what I mean by that. Suppose you had this function, sine of theta minus 50 degrees, let's say. What would you start your table of values at? You would start it at 50 degrees, because 50 minus 50, that would give you 0. So right here I'm going to plug in my thetas, and then right here we'll get our values for y. So we need 5 points in our table, and we're going to start at what makes this 0, and that would just be 0 degrees. Okay, the next 4 points should be increasing each time by the period divided into 4. Why do we divide the period into 4? Here's why. You might remember this from when we talked about the unit circle. When we talk about a unit circle, here's a unit circle. Say we have it looks like this. Why do we divide it into 4? Because there are 4 important parts on the unit circle. There's right here at 0 degrees. There's here at 90 degrees. 180 is another significant point. 270. And then why do we have 5 points in our table? Because when we make a complete circle, we're back at 360. So 0, that 90 is 2, 180 is 3, 270 is 4, and point number 5 will be at 360. That's why our table has 5 points, and that's why we're dividing the period into 4. Because on the unit circle, if you remember, unit circle, the x-coordinate is the cosine, and the y-coordinate is the sine. And as you go around the unit circle, all of the values are covered here. So right here you have x equals 1, y equals 0. Over here x equals -1, y equals 0. These are these blue dots right here. Then you have the top point at 0, 1, and the bottom point at 0, -1. So sine and cosine go through their complete range in the course of 360 degrees. So we'll start by taking the period divided by 4. The period of a regular sine function or a regular cosine function is always 360 degrees. And I'll show you how to find it in alternative cases in the next video. Okay, so we'll take 360 divided by 4. That's going to give us 90 degrees. So that means we're going to increase each time. We'll increase our points by 90 each time. We're going to go up 90 to get the other 5 values in this table. And like I said, we'll do an example when it's not quite as standard as it is right here. So 0 degrees, if we increase by 90, we have 90. Increase by 90 again, we're at 180, then 270. And then 360, our last point should be back where we started. 360 is in the same position as 0. So we made our table, we had our starting point, we made our increases. Now we have to plug these values into the function. So the function here is sine of theta. So we need y equals sine of 0, then we need y equals sine of 90, and then sine of 180, and so forth. And what's nice is that last point, 360, like we said, is going to be the same answer as sine of 0. So how can we get these values? Well, the reason I drew the unit circle up here is so that we can just read them off the unit circle. So the sine is the y coordinate. So if we look at this right here, the y coordinate at 0 is just 0. So this equals 0. The y coordinate at 90 is 1. The y coordinate at 180 is also 0. So let's plot, just move this down a little bit. Let's plot 0 right here. The y coordinate at 270 is -1. And the y coordinate at 360 is the same as it was at 0. So it's equal to 0. Now that we have our values right here, now we can plot these on the graph. You could do this in either radians or degrees. So if you wanted to do this in radians, you would just change 90 into pi over 2. 180 would be pi, and so on. But we'll do it in degrees for now. So we have the point at 0, 0. So that's right here. Then we have a point at 90 degrees, comma 1, which is right there. Then 180, comma 0, which is here. 270, -1, which is right here. And 360, 0, which is right here. So this, what we just drew right here, these dots that I'm connecting, this shows one complete period. And the reason it shows a complete period is because this blue dot right here is the middle of the graph, but it's going up towards a peak. And this blue dot right here is the middle of the graph. And if we kept going, if we continue this graph, it would continue on like that. Actually, that point should be at 450. So it would continue on just like you see right there. It would just keep going. So you've shown a complete period. The period right here is 360. And the way that you find the period is you take the number in front of theta, which in this case is 1, and you divide it into 360. So that turns out to be 360. If I had done this equation instead, suppose I did sine of 2 theta, the period in this case would be 360 divided by that number, divided by 2. It basically would cycle through the function twice as fast, which means a period would only take 180. So this is the number that tells you, 360 divided by that number tells you the period. And then the number in front, I'll put that in a different color, this number in front tells you the amplitude. So the amplitude right here goes from, it has a high point at +1, it has a low point right there at -1. So the distance from 1 to -1 is 2. Half of that number 2 is 1 right here. So for example, another example, suppose I had y equals 8 sine of theta. That means the amplitude of this function would be equal to 8. So this is what the graph looks like, that red graph right there. Let me clear away some of this mess right here. It's called kind of a wave function. A sinusoidal function is the technical name. And it basically is a picture of a wave-like graph. You can see it has a peak and a low point, and it just cycles infinitely through that function. All right, y equals cosine, well, we can basically do the exact same thing. 0, 90, 180, 270, 360, same period, same amplitude as sine. So we'll fill this in. And everything is pretty much the same. The only difference is it's like the values get shifted over just a little bit. So let's fill this in. So we have 0 degrees, 90, 180, 270, 360. If you go back to the unit circle, remember cosine is the x value. So at 0 degrees, the x value is 1. Then at 90, it goes to 0, -1, 0, and then we're back at 1. So 1, 0, negative, and you can see it's kind of like a pattern. pattern goes 1, 0, -1, 0, and then we're back to where we started at 1. Okay, so you can see, and we'll put them side by side in just a sec, you can see the points are almost the same. It's just like it's been kind of shifted over. Same amplitude, same period. There's 270, and 360 puts us back. So you can see we have this kind of function right here. And then let's just keep it going. So we can get a little bit more of a picture. So there's what cosine looks like. If you compare it to the sine graph, you can see they look almost the same. The main difference is this: sine starts at 0, cosine starts at 1, but otherwise they're the same. It's like sine is basically cosine that's been shifted over 90 degrees to the right. So that's how you graph sine and cosine. In the next video we will talk about how to graph tangent.